Problem 2 is also used in Cal 2. We used the trigonometric substitution, and then you are going to include some calculus steps, which I won't go into now. But at the end, you're going to have to turn your numbers back, and it's going to involve a process similar to this. You can do this algebraically, but I am going to show the pictorial method. Now, arcsine of 3/4. I'm going to draw a triangle that has a right angle, and I'm going to consider this my alpha. What I want to do is make alpha so that it's the arcsine of 3/4. The simplest way to do that is to make this side 3 and my hypotenuse 4, because now the sine of alpha is opposite over hypotenuse. If sine of alpha is 3/4, then the arcsine of 3/4 is alpha. The tangent, well, for tangent I need opposite over adjacent. So I need to find the adjacent side. But this is just going to be the Pythagorean theorem. This is going to be the square root of 16 minus 9. This squared minus that squared. That's going to be the square root of 7. So the tangent of alpha is going to be 3 divided by the square root of 7. Since we don't like a radical in the denominator, I'm going to write this as 3 root 7 over 7. Here, I'm going to progress in mostly the same way. I draw a generic triangle, right-angled. This angle is alpha. I want to turn this into an angle, alpha. Now over here I had a ratio. Here I can still think of this having a ratio. X is going to be x over 1. Tangent is opposite over adjacent. If this side is 1 and this side is x, then the other side is the square root of x squared plus 1. Now for secant. Cosine is adjacent over hypotenuse. Secant is 1 over cosine. So I'm going to take my adjacent over hypotenuse and flip those two values. And now the secant is going to be my adjacent side on the bottom, my hypotenuse on the top. So the square root of x squared plus 1 over 1, which is just the square root of x squared plus 1. And these are my final answers.